All right, we are in packet number 3, is linear and quadratic functions, equations, and inequalities. Here I'm providing you with example number 1, and you are asked to determine the x and y intercepts of the graph of the function and state the zeros. Remember, your zeros and your x-intercepts are the same thing. So this is the way I've always taught finding the x-intercepts. I'm going to replace f of x with 0, so y equals 0. 0 equals 4x minus 11, and then I'm going to isolate the 11. So first, in this case, I'm adding 11 to the opposite side. I'm dividing by 4. 11 over 4 is what x equals. I'm going to write it as an ordered pair. There's the x, and there's the y value. Can I have a thumbs up or a thumbs down if this is how you learned how to find, the x-intercepts? Thumbs up or thumbs down? So here's a little trick that I found. When we are working with linear functions, this is the option we have. So when it is in the form y equals mx plus b, and when we know that m is not equal to 0, so m is not equal to 0, which would make it just a constant function that is horizontal to the x-axis, we can quickly find out what the x-intercept is by taking negative b over m. So if I look up here, my m is 4 and my b is negative 11. So watch this. I change the value on b, so positive 11 over 4. That's exactly what I have. Let's try one more before I come back and I figure out what is the y-intercept. All right, so let's try this other one. We're going to go g of x is equal to, let's go with negative 5x plus 7. Again, how would I have done it? I would have replaced g of x with 0 like your y value. This is the way that I learned. This is the way that I taught it for years when I used to teach freshmen. Then I divide by negative 5. Two negatives make a positive. The x is 7/5. I read it as 7/5 0. That's the way I did it. But remember, we do have this trick when we're working with linear functions and m, the slope is not 0. We change the b value, the sign on the b, so it's going to become negative 7, and I put it over the m, which is negative 5. Again, here we go, x equals 7/5. Just an alternative with linear functions. Now let's come back up here. How do we determine the y? How do we determine the y? So just like when we found the x-intercept, we made a y0. Now when we find the y-intercept, we make x0. So f of x equals 4 times 0 minus the 11. F of x equals negative 11. Now what's the shortcut to this? Within linear functions that are in the form y equals mx plus b, this number in the back that's all by itself will always be our y-intercept. So the y-intercept here is going to be 0, 7. Here again it would be 0, negative 11. That's the first type of problem I want to go over. In your notes, please write questions 1 through 5. A lot of this is review from 8th and 9th grade in the beginning of this packet. So now we're provided a slope and 1 point that is on this linear function, y equals mx plus b. I'm going to replace the m with negative 2/3. Notice this is the x and this is the y. Replacing x with 9, replacing y with 7, and I'm solving for the b. All right, it really is like 9 over 1. You can always put 1 on the bottom of any value. So this is negative 18 over 3. Negative 18 over 3. Well, negative 18 over 3, or you could just reduce right away, and we'd end up with negative 6 over 1. Either way, when it reduces, we have negative 6. 7 equals negative 6 plus b. I want to isolate the b by adding 6 to the opposite side, and b equals 13. My goal is to create an equation that's provided this slope and this particular point. So y equals, we have a slope of negative 2/3 x, and we have a y-intercept of 13. This particular example is like questions 6 and 7 from your packet. We're going to go on now, and we're going to do questions like 8 and 9, So I have 4, 12, and 3, 5. And provided these 2 points that lie on a linear function, we want to write an equation of this function. This is x1 and y1 because it's the first point, and x2 and y2 because it's the second point. Remember, your slope is rise over run. Rise is the y. y2 minus y1 over x2 minus x1. Now, I always suggest when you're plugging this in to use parentheses to ensure that we don't have any sign errors. y2 is 5, y1 is 12, x2 is 3, and x1 is 4. Could you make these your x1 and y1 and your x2 and y2? Absolutely. All right, 5 minus 12 is -7, 3 minus 4 is -1, and the slope is 7. It doesn't say what is the slope, it says what is an equation here. So y equals mx plus b. I'm going to replace the m with the 7. And now I choose either point. It makes no difference. You choose which one looks easier to you. I'm substituting, in this case, 3 for x and 5 for y in order to solve for b. So for the x, I'm going to substitute in 3, and for the y, I'm going to substitute in 5. I could have also used 4 and 12, and I have 5 equals 21 plus b. When I isolate the b, I end up with b is equal to -16. So we're supposed to write an equation of this function, y equals 7x minus 16. This is like questions 8. We're solving for y. And so I'm going to go ahead and put a 1 underneath the x. Remember, I can always put 1 underneath any value or variable. And I'm going to cross multiply here. So x times the quantity y subtract 1 equals 1 times y plus 2. Now I'm going to distribute here through to get xy minus 1x equals y plus 2. Okay, my goal is to isolate the y. So I need to put the y's on the same side. So xy minus 1x, now I'm going to move the y to the opposite side by subtracting it, minus y equals 2. And this particular term has no y, so I'm going to move it over to the right-hand side. Opposite of subtracting 1x is adding 1x. xy minus y equals 2 plus 1x. On the left-hand side, I see two terms and they both have a y. So let's factor out a y. Y times 1 times what quantity is xy? Y times x. And y times -1 is -y. We can make sure by distributing that I do end up with xy or yx. They're the same thing. And y times -1. Now to isolate the y is being multiplied by this quantity. So I'm going to divide by the quantity x minus 1, and now y is isolated. I have 2 plus 1x over x minus 1. All right, I'm going to put a 1 underneath the 5 and the x, and I'm going to use what you may recall as the butterfly method or the Macfarlane method. Always start in the top left. So which diagonal you start in doesn't matter. You're always going to go from left down to right for the first one. 1 times x is x. 5 times 4 is 20, and the symbol in between was subtraction. On the bottom, 1 times 4 is 4. Let's do the same thing on the right-hand side. 3 times 1 is 3. X times 8 is 8x all over 8. There could be more than one way to do this. There could be more than one way to do this right now. Did you guys know that if you can get, so I want to go over right now. How many of you would try cross multiplying right now? Cross multiplying. Nothing wrong with that. I'm going to press pause. I want you to cross multiply and solve, and then let's talk, is there another way we could do this? Okay, I'm going to press pause, do it. You should be doing it at the same time. All right, Johnny and Mustafa saw that I multiplied wrong here, but I'm going to cross multiply, so I'm taking 8 times this quantity and 4 times this quantity. So distributing to get 8x minus 160 and 12 plus, this is going to be 32x. I put 24, 32x. Okay, so I'm going to subtract 8x over to the right-hand side to end up with 24, subtracting 12. So I'm combining like terms and then isolating the x, and I reduce it to get a -43 over 6. -43 over 6, and you can see that right here. Bless you, reduces down to -43 over 6. All right, is there a different way that we could do this? Is there a different way? So I'm going to press pause, and I want you to write this. I know that when I'm working with rational equations, when the denominators are the same, I can just cancel it out. So if I could turn this into an 8, life would be really easy. This is an alternative method. So to turn this into an 8, I have to multiply by 2. Now does everybody see how I have an 8? But I still have to keep the fraction with the same value. So if I multiply by 2 on the bottom, I must multiply by 2 on top. Now I have 2 times this quantity over 8 equals this quantity over 8. When we're working with rational equations in this type of a setting, we can cancel at the bottoms, and I'm going to time you. Are you ready? I would like you right now to solve for x. This is a good time management. Can you do this in 1 minute? Begin. We just went over are going to relate to 10 through 14. 10 through 14. We're going to move on now to linear inequalities. Linear inequalities. Here's the very first one I'd like you to write down. Please write down for me 8x plus 2. 8x plus 2 is greater than 10x minus 1. So I'm going to isolate the x's. Remember that your final answer doesn't have to be positive or negative in order for us to flip the inequality symbol. It's whether you multiply or divide by negative. So I'm going to choose to move actually the 10 to the left-hand side. I want to keep the x's on the left-hand side as I organize this. Negative 10x and positive 8x is negative 2x. I have not multiplied or divided by negative yet. Now I'm going to subtract 2 to the opposite side. And now at this point, this is where I want to isolate the x, and I'm dividing by a negative. I don't care if my final answer is positive or negative. The act of multiplying or dividing by negative is going to take the inequality symbol and it's going to flip it. 3 halves, by the way, is the same as 1.5, and I'm going to express this solution set on a number line. Whether you write 1.5 or 3 halves is up to you. Think of this as an arrow after we flipped it. The arrow says shade to the left. So I can choose any value to the left of 3 halves or 1.5, and if I plugged it into this original statement, it would be true. We are not including 3 halves as part of the solution set because there is no line under. All right, how do we solve this and then represent it on a solution set? I'm going to cross multiply. 3 times x minus 1, and then 4 times x plus 2, 3x minus 3, and 4x plus 8. If you see me make a mistake, please let me know. I'm going to choose to move the x's to the left-hand side. So I have negative 1x minus 3 is less than 8. Add 3, I have negative 1x is less than 11. Okay, whenever I multiply or divide by negative, it doesn't matter if the final simplified answer is negative. I need to flip the inequality symbol. Alright, so here's negative 11. I'm making an open circle. Think of this as an arrow, and I'm shading to the right. This represents the solution sets for this original function. So I could choose any number that's to the right, any number that's to the right of negative 11, not including it, and it would make this mathematical statement true. So the problems that we just went over, the 2 problems we just went over, are like 15, 16, and 17 in your packet. Now we're moving to questions like 18, 19, and 20. So we are asked here to identify the x and the y-intercepts. Now the y-intercept in this in the standard form of a quadratic function is really easy to identify. In this form, the y-intercept will be the last number. That's all by itself. It's the last number that's all by itself. So the y-intercept is 0, negative 6. Now how do we identify the x-intercepts? How do we identify the x-intercepts? Well, we're going to replace y, or in this case, g of x, with 0. So 0 equals 2x squared plus 11x minus 6. And we have 2 methods to solve that you have previously learned. One is the quadratic formula, and yes, you have to have this memorized. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. This will always work. Factoring sometimes works, and when factoring works, most of us choose to use factoring when it's possible. So, but we have to know how to use the quadratic formula, because when factoring doesn't work, that's where we're going to rely on. So I'm going to check right now with factoring. 8 times c is negative 12. What 2 values, if they exist, multiply to give us negative 12 and combine to give us a positive 11? That would be 12 and 1. They have to be different signs, with the larger number being positive. So they multiply and they add. So here we go. 2x squared minus 6. I'm going to take these 2 values and drop them in. 12x, and minus 1x. And now I'm going to factor. What can I factor out of this? I can factor out a 2x, and I'd be left with x. This is a plus sign, plus 6. Let's make sure I did this right. 2x squared plus 12x. I'm going to repeat the x plus 6 and back. What times x gives us a negative 1x? A negative 1. Negative 1 times 6 is, in fact, a negative 6. Okay, both the front and the back contain an x plus 6. In front is a 2x, and back is a negative 1. We're going to set each of these quantities equal to 0, and we're going to solve. X plus 6 equals 0, and 2x minus 1 equals 0. This allows us to find the x-intercepts, or the zeros, of this quadratic function. So subtracting 6, I get x equals negative 6. And adding 1 and then dividing by 2, I end up with x equals 1/2. X-intercepts and this original function, this is my y-intercept. I could achieve the same answers using the quadratic formula. Okay, we are moving on now to problems like 21, 22, and 23. I'm going to provide you a basic function. Please write this down. G of x equals x squared minus 12x plus 16. We are going to identify the vertex. The vertex contains both an x and a y point. Remember, the vertex of a quadratic function will either be the highest or the lowest point. So the absolute maximum or the absolute minimum of the function. So how do we do that? Well, in order to figure out the x value, we're going to take negative b over 2a. And you may be wondering, well, what is the b and what is the a? A is the number in front of the x squared, b is the value in front of the x, and c is the value all by itself. So in this problem, a is 1, b is negative 12, and c is 16. X equals negative 12 over 2 times a. Two negatives make a positive, and 12 divided by 2 is 6. So in this position of the vertex, I'm going to write a 6. The vertex needs an x, and don't forget it also needs a corresponding y value. Well, how do you find the y value? We're not using a calculator through any part of this. I'm going to take this and plug it back in. 6 squared is 36. I'm trying to figure out this y, or the g of x value. 12 times 6, let's see here, is 72, right? Is that what you said? Thank you. Oh, and this is a plus sign, not a comma. So 36 minus 72 plus 16. Well, 36 minus 72 is a negative 36. And now I have different sign, I subtract them, and the sign of the larger number is negative 20. This is going to be my vertex. I use this formula every single time to determine the x-coordinate of the vertex, and then I'm able to achieve the y-coordinate by taking this value and plugging it back in for x. The axis of symmetry, if I come up with a parabola here, this is the vertex, and the axis of symmetry for quadratic functions will always cut through the x-axis. So the equation will always be x equals for quadratic functions, okay? Now, how do I determine this? Well, notice that not only does it cut through the x-axis, it cuts through the vertex. And so it's always going to be equivalent to whatever the value of the x component of the vertex is. X equals 6 is the equation of the axis of symmetry. Only saying 6 would be wrong. It's the equation x equals, always x equals for quadratic functions. For most students, they've learned this freshman year, but they really don't like doing it. So we're going to start off with a very easy one. Please write f of x, please no talking, equals x squared plus 12x minus 4. Our goal is to rewrite this in vertex form using the completing the square method. When the value in front of the x squared is a positive 1, it makes this very simple. So we have a positive 1 here, life is good. Very simple. Take whatever the constant is, the number that has no x, and we're going to move it to the opposite side. Now we can be lazy here. I'm allowing you to be lazy. How do I move a negative 4 to the opposite side? Add it. Okay, we can be lazy. Plus 4. All right. The next step is going to be, notice how these both have an x. I'm going to factor, I need to figure out what is this value that goes back here. It's always going to be a plus sign, so we can write always here. And now I'm going to factor. I need to figure out what value goes here so I can factor this. So there is a trick. We're always going to take whatever this b value is, including the sign, And we're going to take that value and we're always going to divide it by 2 and then square it. And whatever I get here is going to go into this position. So positive 12 divided by 2 is positive 6. Positive 6 squared, well, 6 times 6 is a positive 36. And now to write this in vertex form, I'm going to factor this. So the slow way would be, okay, what multiplies to give you 36 and combines to give you 12? Anybody? What multiplies to give you 36 and combines to give you 12? 9 and 4, they don't give you 12 though. That's really close. Anybody else? 6 and 6. And they would have to be both positive. So you'd factor all of this and you'd come up with x plus 6 and x plus 6. And when you have the exact same thing, how do we write it? X plus 6 quantity squared. But there's a trick. I'm going to teach you a shortcut. If you want to do all of this work every single time, go ahead and do that. But here's the shortcut. Write this down, and then in this position, instead of having to factor, this works every single time. Take whatever was inside the parentheses, so there's a plus sign, and 12 divided by 2 is 6. Every single time it works, and you don't have to factor. Every single time. It's a shortcut. Here's my final answer. I'm going to move the 4 back to the other side. Remember, this problem was really an f of x. So f of x is the same as y. I have x plus 6 quantity squared. When the 4 moves back over, it's negative 4. If you graph this on your graphing calculator, which I've asked you not to take out, and your partner graphed this, they're the exact same functions, just in different forms. This is vertex form. This is vertex form. Let's do one more. Let's do one more. This one's going to be a little bit harder. Please write down g of x equals 2x squared minus 8x plus 1. So what is different about this? Can anybody tell me what's different about this problem? Okay, everybody put a little arrow here. Anytime this is different, anytime this is anything other than a positive 1, it just makes one step more. It's just a little bit harder. So just like I did before, I'm going to move this to the other side, and I can be lazy. So I have y. I'm going to replace this without y. When this moves over, please be quiet and back. Whispering. Please be quiet and back. When this moves over, it's going to be a minus 1. And now what's different about this is anytime this is anything other than a positive 1, I have to factor it out before I start. Okay, so we have 2 times x squared, okay, minus 4x, and now I have a blank there. So I've already moved the 1 over to the left-hand side so I can cover it up, and I've factored out 2 of what I have. So 2 times x squared and 2 times negative 4. Awesome. Okay. How do I figure out this value? To figure out this value, it's the same thing that we did up here. I'm always going to take this b value every single time, include the symbol, divide it by 2, and square it. So negative 4 divided by 2 is negative 2, and negative 2 squared is a positive 4. Now, if you like doing it the long way, you'd come off to the side and you go, okay, what multiplies to give us 4 and combines to give us negative 4? And the answer would be negative 2 and negative 2. You do all the work and you get x minus 2 and x minus 2, and then x minus 2 and x minus 2 can be rewritten as x minus 2 squared. But there's a shortcut to doing this. The shortcut is, I'm going to come back to this in just a second, the shortcut is to take whatever this is right here and drop it down. So negative 4 divided by 2 is negative 2. Now, what is different about this problem is that I did not just add 4 to the right-hand side. Nice job. I just added not a value of 4. Yes, there's a 4 there, but in reality, because there's a number out front that's different than 1, I have to multiply that. So 2 times 4 is a positive 8. I added 8 to the right. Now, to keep this equation balanced, because I added this, I just must add 8 to the left. These will be problems like 7 through 27. Your homework before you come in tomorrow is to go 1 through 27, showing all of your work and using no calculators.